I'd love to welcome our first speaker for today in a lineup of around 11. His name is Michael Feindt, and he's the CSO, Chief Scientific Officer, and co-founder of Blue Yonder. And for those of you who don't know, Blue Yonder is developing predictive analytics and focused on supply chain in order for retailers to anticipate what their customers might buy even before they buy it. So very exciting stuff. He's previously a scientist at CERN, focusing on particle physics. So with that, Michael, I'd love to welcome you to the stage.
Thank you.
There's a clicker.
Yeah, thank you very much. So I gave my talk the title, Making Humans Work Smarter with Vertical AI Solutions for Supply Chain and Pricing. That's what we are doing. Actually, we're also automating work, but we as a community have to be careful not to be seen as dangerous and destroying jobs, and so we should be careful there. Actually, we are not. Most of our clients actually hire more people after they introduce AI systems, and they can afford it because then they are more effective, and they do make money, and then they can afford it and make really the work of the humans in the companies also better, smarter and better. Okay, so I'm the founder of Blue Yonder, and Blue Yonder brings digital innovation and disruption from Germany, so also there something happens. And the main background comes from CERN, so I'm originally a particle physicist, and I'm professor at the Karlsruhe Institute of Technology for physics. Founded my first company in 2002, Blue Yonder in 2008, with methods that were developed originally for elementary particle physics, where we had big data, so many tera to petabytes already for many years, and we have lots of raw data and have to get meaning out of that. Okay, and what we are selling now is really value for specific tasks through data and completely scientific software, which is nowadays called artificial intelligence. Okay, what makes machine intelligent? So there, in my view, there are two main branches in artificial intelligence. The first one is to learn that a human can do well. And this is, but a computer cannot do easily. That is really seeing, recognizing images, understanding a voice, a text, things like that. And there, Moore's law and deep neural networks have done, and all of you know that, tremendous progress in the last years. And on the other hand, it is intelligent algorithms that can be or are reconstructed partly also using domain knowledge for a concrete problem, but then also data and machine learning in order to become as good as the best human or even better. So a good example for that is the beating the world champion in Go, for example. Right? And sometimes that is also sometimes not really too much, but for commercial applications is important. It also has to be affordable. So you cannot always train huge networks if you already if your data set is already many billion individuals large. You also have to think about resources. So it's not only deep neural networks, it's also other algorithms, and to my mind, which are important, which are much faster and do not need so much resources. Okay, so what we are doing is essentially optimization of decisions and also the automation of decisions. And these are not the important personal and professional once in a lifetime decisions. Those are done by gut feeling, and this will stay so. This will be completely human always. I'm completely convinced. But you can, in a normal enterprise, the decisions that are taken there can be automated and by artificial intelligence driven by actual data. More than 99% of these decisions can be automated, and that's what we are actually doing. These are decisions, these are repeated decisions, which come again and again in a similar setting. For example, if you're in a supermarket and you have 20,000 articles, which article to order today? And then you have 500 stores, and there are many, many such decisions, and every day you have to ask this again, right? Or to set a price for a specific item at a specific date. Who to send a catalog from your 1 million or 2 million long list. So what people actually are doing when they do again have to decide these things, that most of the time they do nothing, or that is the same as always, just default, don't think, right? Some use business rules, which might be good or not be good, and really to think about a single decision. How many should I order? Oh, now the weather is so, and there's a holiday, and so this almost never happens. Right? Very, very, very seldom. And we have to also to know how the human brain functions. Our decision making is done mainly 99.9% by the first system one. It's a fast intuitive system, gut feeling, experience. We don't think really rationally. And only very few decisions are done by our slow rational system. And human decisions also have a lot of biases, and I will show you one later. And one can read about this, for example, in the book here by Nobel Prize winner Daniel Kahneman, that even experts do many, many, many wrong decisions because we are humans and our system one rules, not the rational system. And system one cannot speak statistics, for example. Right? That's very important to know. So what we are doing is predictive analytics and prescriptive analytics. I will show what it is in the next slides. And these are both disciplines of machine learning, and machine learning, again, of artificial intelligence. So many people who are not experts are completely confused, and they think, oh, now machine learning is out and artificial intelligence is in. This is, of course, nonsense. But non-educated people don't understand these things. So that's why I also always show transparencies like these. So, but that's the thing how one should do decisions nowadays. Based on data, on objective data, do a prediction of what will happen in the near future, including uncertainty, I show that. Having a cost or utility function, what does it cost me or how good is it for me if the truth will differ from my prediction on the low side or on the high side, right? Then do an optimization for a decision that I have to take. And if I have to do all this here very often, automate. This is a recipe for better decisions in the age of AI. So when can we use predictive analytics? Very often you can do. Most people think that the world is actually or have a too deterministic view of the world. So here one, of course, expert can calculate what will happen exactly, right? But on the other side, you have, for example, drawing of lottery numbers, and it's completely random, right? Every week the same is done, but every week other numbers are coming out, and it's completely unpredictable, can be proven, right? But there's a complete spectrum of things in real life in between purely random and purely deterministic. For example, how many of these apples will be sold tomorrow? Right? So it's not clear today. We don't know. Right? There are so many. This is also a chaotic system. We can never say for sure how many will be sold. But of course we can say something. It will depend on the weather, on the price, how they look, and so on. Right? And that is exactly what we are doing. So with many, many inputs, for example, the weather, but also the weather forecast for tomorrow, the price, promotion, competitor prices, and blah, blah. So many, many possible influences are there. And we have many individual, what we call events. There are many items in the store. A supermarket chain has many stores, and we have many days. Right? So data set of 5 years for typical supermarket chain is already 12 billion or 20 billion rows long. And for each of the rows, you have in principle all these columns, right? So lots of valued, of measured quantities. Okay, a prediction for a standard is just a number, 250 apples. But we know it will not be 250. It might also be 260 or 280 or 100 only. Right? For us, a prediction is a complete probability distribution for each of these possible futures. That's way more information. Right? And once you have this, then you can also do a complete risk management of every single decision. Right? And this contains all information that you can give now. It should be as narrow as possible, that means as precise as possible, but not more as allowed by laws of nature. right? So, and for optimal decisions, it's important also to have the uncertainty, not only the one number. So in standard ERP software, a prediction forecast is only one number. There is no uncertainty and no tail risk and so on inside, right? In Blue Yonder software, there is. There's a big difference. But now, the probability distribution is difficult to handle, right? So nobody can do something with it apart from mathematicians. But we can do. For example, for the best ordering decisions, we have to know then the cost function, utility function, and that depends on, for example, you don't want to be out of stock. You don't want to have lost sales, but also you don't want to throw away articles after the end of the shelf life. So depending on input on purchase prices and on shelf life and other quantities, one has individual cost function also, right, for each single item. And if you have such probability distributions and cost functions, then you can actually find the optimal decision. And that is what we are doing, for example, for a supermarket chain, about 15 million such decisions per day. Right? And the result is a recipe, order so and so much, right? But of course, if you have so many, then you should also automate that. And that automation is really important. I show you on this slide here. So this prescriptive analytics gives you a list with all what you should do, but then people still don't do it because they don't believe it. Their system one tells me, no, I know I should buy less here and more there. And so this is real data from a client from us. So here the out-of-stock rate of about 7.5% before we started. Then we started giving prescriptions. So it went down to about 5% and with also a bit tendency downwards. And at that stage, then they said, our client said, okay, we trust the system. Now we do it fully automatic. Right? So, and what happened then? It went down to 0.5%. Because this was all the recipes that were not accepted by the human factor, right? And then it stayed there. And that was a decision at a constant overall stock level and waste rate. So you can more or less bring down the out-of-stock rate by a factor of 10. So what you can achieve, and this is also very important here, so any decision, management decision is always a compromise between optimizing different KPIs, right? If you order too many, then you have waste. If you order too few, you have out of stock. So whatever you decide, you're on somewhere on such a curve, right? But if you want to improve one, you're getting worse in the other. And by breaking down now this management decision to every single decision, to millions of decisions per day individually, right? You can achieve both aims simultaneously. You can have less write-offs and less out of stock, right? So essentially, you go to a more efficient frontier curve. Okay, so what we achieve for supply chain in retail is 99% automation, less write-off, less waste, better freshness. So the freshness of each single article item in the store is on average longer lifetime, less capital binding, less out of stock, more turnover, more efficiency. That really works great. So one example here from the UK is we did it just last year for Morrison's, number 4 in grocer in UK, and that worked very well. So we are doing 13 million automatic ordering decisions per day, and that led to about to more than 30% reduction in shelf life gaps. And actually, Morrison's is the one retailer with the largest growth rate of the classical retailers growth rate in this year, and its equity price went up again, and so on. This is very, very positive. And this now also you can ask here: are the people working at Morrison's fine with that or not, or do they feel bad? And there we have just had in the grocer this article, which was very nice. Now what we are doing is actually we make our customers work smarter, and Morrison became store of the week, and this is a quote, the new system, so the replenishment system, has made a big difference, not just in terms of maintaining great availability, but on the amount of stock we need to keep. They keep much less now. Actually, their back store is, they can close down more or less the back store and make it also sales area. And the other thing is moral is really high in the store. And there was a mystery shopping, and Morrison's won here completely against Asda, Sainsbury, Tesco, and Waitrose because of that. So very positive, and people like it. They don't want to sit every day in front of a screen and say yes, 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 no, yes. They don't want it. They want to really serve the end consumer, and that's way more powerful. For Kaufland, the German grocer, we do meat replenishment, the complete supply chain up to the production plant. So, and also that works also very well, and it reduces write-offs. And write-offs for meat means also, if you bring it down the complete supply chain, that less animals have to be killed. So that is certainly something positive. For Otto, Germany's largest distance retailer, I mean, all of these companies are now threatened by Amazon, and because Amazon is a completely data-driven company, and that gives a big advantage in everything. So for Otto, for example, we are also doing predictive shipping. They originally had 5 to 7 days to deliver for their marketplace articles, marketplace items. Now we reduced it to 1 to 2 days because we make already predictions of what will be ordered tomorrow, the day after tomorrow, and so on. And they pre-order it from the suppliers and have it there just in time. And so that is also very, very successful. And it will be rolled out now to more than 2 million items. Price is another thing. Pricing is also it's a very delicate problem to set the price right. The price now is also, this is from a mathematical point of view, difficult because now a price is something where we change the system, right? And so this is something where one really has to distinguish between correlation in data and causal effect. We have to predict the causal effect of changing the price given all the rest from historical data and actual measurements, and then to adjust prices. Depending on online, it may be very often. Offline, in brick and mortar stores, it's usually very seldom. And what we achieve, again, is something like 99% automation, more market share, more turnover, more raw profit. So these are things that usually cannot be achieved simultaneously. Because if you make all the prices higher, you get more market share but less profit, right? But here you can increase all of them simultaneously. More customers, more new customers. That's also not due to high prices, of course. Less returns in online retailing. No complaints. That was all our clients are very very worried here, but that's very important. So this is accepted. And that is also very interesting, for example, for fashion, no rest at the end of the season. So that what is called markdown pricing, one can do this with artificial intelligence way, way better than just keeping price constant all the time. And the last weeks, you almost give it for free. So this is an example from my old life here. So artificial intelligence can actually also change the very, very intellectual work. So what we have done here is to actually change or automate a part of the work that a research physicist does as an accelerator center for a Japanese experiment called BEL. We have so I had a lot of PhD students, I'm a researcher there, so I knew exactly what happened, and we made a systematic out of it and found that usually a PhD student has to do 72 decisions in such an analysis, and we automated and optimized all of them and ran then the 10 years of data taken by the experiment on the new program, and the result was that it found more than 2 times as many B mesons, that's the task of the experiment, correctly reconstructed than the 400 physicists in 10 years, including myself, before together. And so it was the work of artificial intelligence and 3 PhD students, corresponds to about 500 normal PhD theses. And in the next generation of accelerator experiments that will start in 1 or 2 years, this thing will happen directly online, directly at data taking, and in the meantime, it's already another factor of 50% more efficient. So what's interesting is this experiment costed the taxpayer just the operation of 10 years, 700 million euros, and we doubled the physics output of that with this work, right? So way more efficient. Okay, another thing that we're also doing for particle physics has not so much to do with that, but our decision algorithm, the NeuroBayes algorithm, we also implemented on a chip, because for the next generation of experiments, there will be so much sensor data that it cannot be read out into computers anymore. Because there are so often collisions and so much data that it's impossible to read out. Now, for the time being, at CERN, about 30,000 computers in parallel do then a scaling down by a factor of 1 to 10, 100 million, so-called trigger system. But this will not be possible anymore because it cannot be read out into parallel computers. And for that, we put in our decision on an FPGA and put this directly on plates of sensors. And that it decides which part of the sensor should be read out at all. So it could be interesting for Industry 4.0, of course, right? And this has now a world record of, we think it's a world record, of 8 billion decisions per second, intelligent decisions per second. Okay, that is where I think really an important task of AI will be, and these are vertical end-to-end solutions. So specialized providers as Blue Yonder combine expertise and experience solving complicated business problems by AI and machine learning, combined expert domain knowledge with AI. That's I think the important thing. So in order that it really solves problems, you have to know something about the domain and the task. But then usually, I think that was a statement of Amazon also, but there is nothing that you showed before. Every enterprise can be optimized by AI. Yes, I completely agree. Right? And that is exactly what we are doing here. And it has to be put into consumable, robust solutions, right, for specific tasks, ready to deliver proven value and competitive advantages fast. To be accepted and to be used, yeah, I'm ready. That's the last transparency. To be ready and accepted and used, this is important that it is also consumable for non-experts. Most of the people in the world are not experts in AI, of course. And I also think we have to hide complexity and provide it as a service and allow, then the service has to allow people to work smarter. Okay, that's the end. Thank you very much.
I think we have time for 1 or 2 questions, if anybody has any. Choices from behind you. So sorry, if you... Yeah.
Trian, founder of Quizdom. My question is, how much effort in terms of time and personnel was necessary to implement your algorithms at the German retailer?
Okay, so good question. That is something that by production and experience goes down and down and down and down. Right? So actually it's from the first contact there to actually have it runs on in first stores, that took about 3 months. And the complete rollout, including the change process, there was also quite fast. It was about a year to roll out completely over 500 stores. But that is, of course, right. That is an important thing. But we understand us as a product company, and that is exactly where we work on that. This goes as smooth as possible and is assisted as well as possible. That was a question.
So this is Robin from Similar.ai. To what extent do you use common sense knowledge about the items which are being sold? I think most retailers just see items as items, and they don't understand what they are. do you use any kind of everyday knowledge about the inherent characteristics of those items and how they're related to other items in order to make your predictions?
Yes. Okay. Yes. So let's say this way: an article or an item is not only an article number, right? It has yes, we know what it is. We know what it is. We have descriptive variables, and these are important, especially if one has no history for this article. So we do all this also for completely new articles. Right? So that is an important thing. By just whatever, we know what's the brand, what's the price, what's its make, and what is it, and how near is it to other articles that have existed before, and that's then how we learn. And in this case, of course, the width of the distribution is larger, right? So we are not as certain as if we already know how this article, this item behaves, really measured. That's another thing. But that's a good thing. Since we always have the complete probability distribution with the uncertainty, this is completely handled automatically, and all the decisions are always optimal with the current knowledge.
Where do you get that data from?
Pardon?
Where do you get the data from on what that article is, on its inherent characteristics?
We get this from our customers. So I mean, these are the description, just article descriptions and so on. Yes, yeah. Mainly yes, yes. We also add external data from where it's good for. For example, weather forecasts, historical weather forecasts, and so on. That's not so easy to get, right? And all, of course, holidays and whatsoever. Also based on the location where we just are.
All right, thanks so much, Michael. Let's thank him.